Yeah, here we are. Tips and tricks. We have some super wisdom Vanya is going to share with you with regard to the machine learning and chemistry, primarily Lab 10, but hopefully you'll be inspired to take advantage of this for your projects as well, because these are cool techniques that are relatively easy to apply to your data set. So without ado, here's Vanya.
Yeah, of course. Hi, I'm Avanya. So today we're going to be covering 5 topics related to the machine learning and chemistry lab. So the first topic we're going to be covering is what is machine learning. The second one is going to be train versus test. The third one is going to be nearest neighbors, the concept of nearest neighbors, and then that's going to lead into the Euclidean distance formula along with root mean squared error. And then at the end of our slides, we'll have like some time for Q&A. Let's get started. So the first question for the slides is, what is machine learning? So machine learning is basically the use and development of computer systems that are able to like learn and adapt without following explicit instructions. And so you may be wondering what exactly that is, but it's basically where you're training a computer to like utilizing like algorithms and statistical models to be able to like perform operations by itself. And so by doing this, by like training your model through like machine learning, you're going to be able to like draw inferences from patterns in data that will allow your machine to work on its own by the end of the lab. Well, hopefully by the end of the lab. Yeah, and so like there are 3 subcategories of machine learning. The first one is supervised. So this is where like machine learning models are trained with labeled data sets, which allow the models to like learn and grow more accurate over time. And then the second one is unsupervised. So here models can find patterns or trends that people aren't explicitly looking for. So that means like if you are training your data and you want it to pick up on like a certain pattern, but it ends up picking up on a pattern that you didn't even know was there, that's kind of like an unsupervised type of like machine learning. And then the third one is reinforcement. So here it trains machines through trial and error to take like the best action by establishing a reward system. I know a lot of times people use like the question of like the railway tracks along with like one person on one side and then like a family on the other, and it asks like people like if like a train was programmed to run through the track, which way would it go based off of like the way it's programmed. And so like here I'm tying that example to here because a huge question when it comes to like reinforcement machine learning is like a matter of like ethical guidelines. A lot of people want to like kind of like whenever they're training their models, they want to make sure that like whatever the best action they're getting their models to take is ethical. So that's a little bit about like reinforcement. And so the next topic we're going to be covering is train versus test. So this concept is in relation to question 1. So here you're required to split your table into 80% training and 20% test. So now we're going to get into exactly why. So what is training data? So training data refers to the initial data used to train the model. And so by using training data, the model can gain knowledge and become more accurate in its predictions. And so the size of the training data is typically larger than the testing data, which is why in the lab you can see that we want you guys to split the data into 80% training and then 20% testing. So let me go back. Yeah, so this is training data. And then what is testing data? So testing data is used to evaluate the model's performance. So until like evaluation, the testing data isn't going to be exposed to the model. So that allows you to ensure that the model isn't like learning the testing data by heart and like producing like flawless like results because they already are familiar with the testing data. So you want to make sure that like when you're separating your data, you still have like a good percentage that allows you to test your machine. Because if all of your data was training, then you don't have like data to test your model with. So you won't be able to figure out like if you've tested like your model, like trained your model properly. So that's why like the size of the testing data is also typically smaller than the training data, because you don't want to like have like 20% training and then like 80% testing, because then like you haven't trained your like model enough. And so then what do we need? Uh-oh, go back. So it says, I can't even see the head. Okay. It says, why do we need training and testing data? So like I was saying earlier, training data teaches the machine learning model how to behave, whereas testing data assesses how well the model has learned. So training data, it'll like allow us, like when we're training our like machine learning model, it's going to be like taught how to generate predictions and perform specific tasks using this training data. And so because like every like the data is like purely like identified by the machine learning model, every data's output from like the model is known. And so like in order to provide predictions, like the model must first learn to recognize patterns in data. And so then with our testing data in our lab, we're going to be like assessing like the performance of our machine learning model after it's been trained. And so like the reason why, like I was saying earlier, this is important is because for like the testing data, you can really see like the model's accuracy in predicting outcomes while it's like assessing the data. And so then, oh, why is it important to separate testing and training and testing data? So number one, it's like to avoid overfitting. So it's like I was saying earlier, it's essential to use separate training and testing data. That way, like when you're like testing, you have like new data to work with, because if you don't separate it, then like the training data you might have like may not be like sufficient enough or like representative to like real world data on which the model will be used. So then the next concept we're going to be covering is k nearest neighbors concept. So this is aligned with question 2. And so here so the k nearest neighbors algorithm. So here it's a number that tells like the algorithm how many nearby points, aka neighbors, like to look at when like making a decision. And so I gave the example of like, imagine you're deciding which fruit to pick based on off of its like shape and size. If you compare it to like other fruits, you like if you compare this fruit to other fruits that you already know, if k is equal to 3, the algorithm looks at the 3 closest fruits to the new one. And then if k is equal to 2, of those 3 fruits like being apples and one is banana, the algorithm says that the new fruit is an apple because most of its neighbors are apples. And so selecting like the optimal value of k. So here I'm going to just like go over like the steps of like algorithm. That way you guys can link it to questions on the lab. So like I was saying earlier, I believe this is question 2. So here you're asked to select the optimal value of k. And so like k represents the number of nearest neighbors that need to be considered when making a prediction. And so step 2 would be to calculate this distance between these like nearest neighbors. And so this allows to like measure the similarity between like the target and training points. And so here, this is where you use like the Euclidean distance. And so the distance is like calculated between the data points in the data set and the target points. So whenever you're trying to find your nearest neighbors, the k data points with the smallest distance to the target point are the nearest neighbors. And so then whenever you want to like classify an extra step, like when you're like trying to take the average for like regression, when you want to classify a data point into a category like spam or not spam, the k nearest neighbors algorithm looks at the k closest points in the data set, and then these closest points are called neighbors. And so how to choose the value of k for your k and algorithm. So the value of k is critical when like trying to determine the number of neighbors like to consider when making predictions. So like selecting the optimal value of k depends on like the characteristics of the input data. So if the data set has significant outliers or like has like or like noise, like a higher k can allow you to smooth out those predictions and reduce the influence of like the noisy data around it. So while this is beneficial to like pick a higher like K value whenever like the data points are really just like everywhere, like a high value can also be lead to like it can also be underfitting, because then it'll make the model like a little bit too like simplistic, because you have such a high like K value that like it kind of like diminishes like how it's kind of like when you like when it's like the data is like too big, you can't really distinguish like what exactly is like important to look at, because it's just like so high. So then now we're going to get into the Euclidean distance. So for the Euclidean distance, I'm going to be talking about what it is and why it's important. So the Euclidean distance measures the length of the shortest line between 2 points. So it's commonly used in like machine learning algorithms. So here is the Euclidean distance formula. So the exact point, it'll be, so you're going to have square root parentheses x test. So the x testing data subtracted with the x training data squared, and then plus the y testing testing data subtracted with the y training data, and then you're going to square both of those numbers up. You're going to square both of those numbers up, add them together, and take the square root of that. And so, like I was saying earlier, the reason why you do this like subtraction with like the test minus the train is you want to see that distance between those two values, and like factor it in whenever you're calculating the Euclidean distance. That way you can see like how well your model is like working. And so here we're going to cover the root mean square error. So this is for question 5. And so basically what the root mean squared error is it's a metric used to evaluate the accuracy of a regression model. So it measures the average magnitude of the difference between like the predicted and actual values. So like the root mean squared is essentially the square root of the mean squared error. And so like a lower RMSE indicates a better fit model, as it means that like the predicted values are closer to the average, are closer to the actual values on average. And so then here I've given you guys like the formula for the root mean squared error. And then this, like I was saying earlier, is tied to question 5. So I know that you guys have a discussion question along with this one. So like whenever you're explaining exactly what the root mean squared error tells you, make sure that like you look at whether it's like lower or higher than what's initially been given to you. That way you can see if it indicates a better model fit or not. And yeah, that's the end of like all the slides I have for you guys. So